For the second part of the lecture video, I'm going to show you some proofs of the differentiation rules. So let's start with the first rule, which is about the derivative of a constant. That is, if a function is defined by f of x equals c, where c is any constant, then the derivative of f is given by d over dx f of x equals 0. So the notation d over dx is one way to denote the derivative of the function. And the other one that you already know based from the previous discussion is that your f prime. That is f prime of x is equal to 0. So if you have a function f, let's say for example f of x equals c, the derivative of any constant c is 0. So we have f prime of x equals 0 or d over dx f of x equals 0. So by the limit definition of the derivative of the function, we can show the proof of this um, rule of the derivative of a function, of a constant function. That is, f prime of x is equal to the limit of, we have f of x plus h minus f of x divided by h as h approaches 0. So since f of x is a constant, in terms of the composition of the function for x plus h, this will be the constant again. So we have c minus c divided by h as h approaches 0. And c minus c, this is equal to 0. So we have the limit of 0 divided by h as h approaches 0, and 0 divided by h is equal to 0. So the limit of 0 as h approaches 0, we know that this will be equal to 0. So f prime of x is equal to 0. And this is the derivative of any constant. Say, for example, we have g of x equals 5. Thus, for the derivative of g, that will be equal to 0. Even if that h of x equals negative 1,000, its derivative is still 0. Okay, so that's for rule number 1. Rule number 2, we have the derivative of a constant multiplied to a function. If c is a constant and f is a differentiable function, then d over dx c f of x is equal to c multiplied by the derivative of f of x. So again, using the limit definition of the derivative to show the proof of this rule, we will have c of f of x. Okay, let's write d over dx since yun yung nakalagay dito sa statement natin. We have the limit of, since this is c of f of x, that means for our f of x plus h, that will be c times your f of x plus h. Okay, so that is c of f of x plus h, because if you evaluate the function times the constant, hindi naman magbabago yung kanyang composition. Okay, especially if you have this um, value constant multiplied to a function. So this will be c times f of x plus h minus our c times f of x divided by h as h approaches 0. So as you can see, for the numerator of our rational expression, each expressions or terms rather have c. So pwede nating i-factor out yung c sa numerator, and sa entire limit operation at the same time, we have c times the limit of f of x plus h minus f of x all over h as h approaches 0. And if you're going to observe, after C, ito na yung ating limit definition ang derivative ng function. So, this is now c times our d over dx f of x. And d over dx f of x means, again, derivative of the function. So, we were able to show or prove that the derivative of c multiplied by a function is equal to c times the derivative of the function. So that is for our second rule. For example, we have h of x equals 5x. So, for us to determine the derivative of this, we'll have h of prime of x is equal to 5 times the derivative of x. And if you don't know yet the derivative of x, we are going to proceed with rule number 3. Okay, but for the meantime, we have 5 times the derivative of x, whatever the derivative of x is. Okay, so let's go to the third rule, which is the power rule. Okay, so for this power rule, we have if n is a positive integer, then d over dx x raised to n is equal to n times x raised to n minus 1. So for the proof of this um, rule, we have to restrict first the value of n to be a positive integer. Okay, so first you are going to restrict that n is a positive integer. Okay, note here that n is a positive integer. So that f of x is equal to x raised to n. Again, we just take note that x raised to n be equal to f of x. Now, using the alternate limit form of the definition of the derivative, we have f prime of a equals the limit of f of x minus f of a divided by x minus a as x approaches a. Again, this is the another formula for the limit definition of the derivative. And since we know that f of x is x raised to n, we take note of that just a while ago, we have x raised to n minus our f of a, that will be a raised to n divided by x minus a as x approaches a. Now, let us expand the numerator so that we can simplify or find the limit of this function. So, if we are to expand this x raised to n minus a raised to n, this will be equal to, let's write here the limit of, medyo mahaba-haba yan. Okay, so if we are to expand this, we'll have, that's the product of x minus a, and that is x raised to n minus 1 plus ax raised to n minus 1 plus a squared x raised to n minus 3 plus until a raised to n minus 2x plus a raised to n minus 1 divided by all over x minus a as h approaches, or as x approaches a. Now, simplifying the rational expression, x minus a divided by x minus a, this is equal to 1. So, we now have the limit of x raised to n minus 1 plus a raised to x raised to n minus 1 plus a squared x raised to n minus 3 plus until a raised to n minus 2x plus a raised to n minus 1. Okay, as x approaches a. Now, if we are to take the limit of the function as x approaches a, what will happen to those terms with x? Okay, so this will be now a. So they are now a. So this is for the fourth step, a raised to n minus 1. Again, just change x by a or x by a. Okay, so a raised to n minus 1 plus this is a, and then a n minus 1. Again, ito sila. And this, so a and a here, yung yung x kanina, we change this to x because we take the limit of such expression. Plus a squared, a raised to n minus 3 plus until a raised to n minus 2, a plus a raised to n minus 1. And now, if you're going to simplify this entire expression, as you can see, each term you have a raised to n minus 1. Yung last term mo din is a raised to n minus 1. How about those middle terms? So if we are to simplify them, meron kang a times a raised to n minus 1. And we know that ang exponent ng a is 1. So we have 1 minus 1 that is equal to 0, right? So that is now a raised to n minus 1. And then we also have here, sandali, mukhang may i-check lang ako about this. We have also, tama naman. Okay, we have here a raised a squared times a raised to n minus 3. So 2 minus 3 is negative 1. So that's n minus 1. And then also here, we have 1 as the exponent of this. So it is now a raised to 2 minus 2 plus 1. That's negative 2 plus 1 or negative 1. By the way, yung mali pala kanina is this one. Kailangan ito ay 2, right? This is supposed to be 2. Yan. And also here, this is 2 also. Okay? So, we now have, let's check again. A raised or a times a raised to n minus 2. That's 1 minus 2. That's negative 1. And then n. So, a raised to n minus 1. So, if we are to simplify each terms of this expression, they are equal to a raised to n minus 1. And how many a raised to n minus 1 meron tayo dito? We have total of n. So this is n times of a raised to n minus 1. So f prime of a is equal to n times a raised to n minus 1. So now, if we are to change a into x, we have f prime of x equals x raised to, or n rather, x raised to n minus 1. Okay? So, this will be the proof for rule number 3. Now, going back to the previous example about the derivative of h of x, we have h prime of x equals 5 d over dx x. So, paano ba malalaman ang derivative ng x? That is by the power rule. That is, meron tayo ditong 5, as is na 5 na lang siya. And then for the derivative of x, we know that its exponent is 1. So, for its derivative, yung kanyang x raised to 1 by the power rule, this is now 1 times x raised to 1 minus 1. And 1 minus 1 is 0. So, 1 times x raised to 0, we know that x raised to 0 is equal to 1. And 1 times 1 is 1. So the derivative of x is equal to 1. And therefore, this is 5 times 1. And 5 times 1 is 5. So h prime of x is equal to 5. So I'll give you another example. by applying power rule and at the same time the constant multiple rule. So let's say for example, we have m of x be equal to 3x raised to 2. Okay? So by constant multiple rule, this will be m prime of x equals 3 times the derivative of x squared. And para mahanap ang derivative ni x squared, we need to use the power rule. Okay? And this is now 3 times sa x squared, ang exponent natin is 2 and this will be equal to n. So with that, we will have here 2 times our x raised to 2 minus 1. Okay? And that will be 3 times 2, 6. And then x raised to 2 minus 1, that is 1. So, ang derivative nung x squared is 2x. And 2x times 3, we have 6x. So, m prime of x is equal to 6x. Instead of using the limit definition of the derivative, pwede nating gamitin itong mga itong mga rules na tinuturo ko para madaling mahanap nga yung derivative. Okay? That's rule number 3. Rule number 4 and number 5, this is about the derivative of sum and or difference of functions. So for the sum rule and or difference rule, unahin kong ituro yung sum rule, pero yung difference rule, I want you to prove this on your own by following the steps that I'm going to use for sum rule. Okay? So for the sum rule, let's write here. Again, we have if your function h is the sum of f and g, then the derivative of h will be the sum of the derivative. So we have the derivative of the sum is equal to the sum of the derivatives. And for the difference rule, the derivative of a difference, that is the derivative of the first minus the derivative of the second. So for the sum rule, lagay ko lang dito, sum rule lang ito. For the difference rule, kayo na yung try mag-proof on your own. We'll have, again, our f of x plus g of x. So let's have d over dx. Okay? And by the limit definition of the derivative, this is equal to the limit of, since that's sum of two functions, then yung ating x plus h, we are going to substitute that both for f of x and g of x. So this is f of x plus h plus g of x plus h minus, ito namang para sa f of x natin supposed to be, siya na ngayon si f of x plus g of x. So we have to, again, include g of x in this case. Huwag niyong kalimutan yung g of x. So this is the quantity f of x plus g of x. Okay? So, divided by, at this point, h, as h approaches 0. So, if we are to rearrange the term in such a way na magkasunudan yung f and then another f followed by g and another g, this is now the limit of f of x plus h. Ito ay minus f of x. Take note, f of g of h minus f of x. Okay? And then, that is now followed by plus g of x plus h minus g of x. Okay? Divided by h as h approaches 0. Now, as you can see, when we rearrange the term, nagkaroon tayo ng parang dalawang groups. We have first group for F and then the other group for G. And since yung denominator natin is H, pwede siguro natin itong i-break into two fractions, right? So breaking this into two fractions will give us the limit of f of x plus h minus f of x divided by h as h approaches 0. Since we're going to break this into two fractions, of course, yung limit expression natin ay meron sa isang part and then the other part. For the operation, as you can see, yung magiging operation natin is addition. Okay, we'll follow this operation because in this case, hindi na naman magbabago yung subtraction dito once we use addition, right? So this is now g of x plus h. Sorry, kailangan ng limit. Don't forget the limit expression. X plus h minus g of x divided by h as h approaches 0. And right now, we have the limit of two expressions. And both expressions denote the derivative of the function, right? Derivative of g and derivative of h. So, we have here now the derivative of f that is denoted by d over dx f of x, and derivative of the second, which is g, we have d over dx g of x. Or if you want to write it in simple way, f prime of x plus g prime of x. So we have d over dx f of x plus g of x. So this is the proof now for the sum rule of the derivative of two functions. Okay? So, let's say for example, okay, magbigay tayo ng example about this. If you have h and h is equal to 5x minus 3, to find the derivative of this, or let's say plus na lang para magtugma naman siya doon sa ginawa nating proof, we have the sum of 5x and 3. For its derivative, we'll have h prime of x equals, take the derivative of 5x plus the derivative of 3. And alam natin na ang derivative ng 5x based on the previous example, and derivative din ng constant multiplied by a function x, we have 5, and derivative ng constant, this is 0. So h prime of x is equal to 5. Okay? So another example, let's say m of x is equal to x cube plus 3x. Okay? Or let's use minus naman para magkaroon tayo ng example about subtraction. If we are to take the derivative of m of x, this will be by power rule. So we have x cube minus the derivative of 3x. Okay? And derivative ng x cube using the power rule, this is 3 times x raised to 3 minus 1 minus derivative of 3x, that is equal to 3. So simplifying this, we'll have 3x squared minus 3. And that is your m prime of x. So by sum and difference rule of functions. Okay? So that is for rule numbers 4 and 5. Now, for rule number 6 about product rule, we have the function h, which is product of h, f, and g. The derivative of h is given by h prime of x is equal to f of x g prime x plus g of x f prime of x. Or simply, h prime is equal to fg prime plus gf prime. Take note that for this one, ang derivative daw na gusto niya is, una, product nung f function and derivative ng g plus your function g times the derivative of f. Okay? So, magkaiba ang fg prime sa fg and then prime here. Ibig sabihin, kapag nasa loob ng parenthesis yung f and g, after which apostrophe, meaning derivative nung f and g. Pero kapag f, g, tapos the apostrophe, meaning we are going to take the product of the function f and yung derivative ng g. Okay? So, for the proof of this one, of this problem, or of this rule, we are going to use the limit definition again. Okay? So, this will be um, f of g prime. So, take note of the symbol or the notation. This will be equal to the limit of product of 2. That's x plus h times g of x plus h minus f of x, g of x divided by h as h approaches 0. Next is, if you are going to observe, parang, okay, nalahanap na natin yung derivative niya. What else? Okay? What will be the next step? How are we going to transform this in such a way na ma-follow natin or ma-prove natin itong statement na to? So, at this part, magkakaroon tayo ng konting manipulation dito sa part ng ating especially ng numerator. Okay? What we're going to do is we will add and subtract an expression in such a way na parang magkakaroon ka ng extended terms pero that extended term will be equal to 0 only. Kasi mag-add and subtract ka ng the same term. So, ano ba yung kailangan nating i-add or subtract na term? We are going to add or subtract f of x plus h g of x, by which ma-prove natin yung rule na ito. Okay? So, that is the limit of, lagay na lang natin siya sa gitna. We have f of x plus h, g of x plus h, and let's subtract f of x plus h, g of x, and add the same term, x plus h, g of x, and our minus f of x, g of x. So as you can see, we subtract f of x plus h, g of x, and then add the same term. So that is 0 lang din. Right? Parang negative 3 plus 3, 0. So, it will not really affect or change our function. So, at this point, we will have to rearrange the terms. Okay? You will rearrange the terms para magkaroon tayo ng somehow this adding and subtraction will make sense. Okay? And that part we will have now for this notation, the limit of, okay, ano ba? Yung pwede natin ditong mapagsama-sama. Okay? And that is f of x plus h, g of x plus h, minus our, nasaan siya? Yung ating g of x. Okay? Saan naman galing yung ating f of x, g of x. So, as you can see, meron, if we are to identify this, meron kang f of x, g of x, and another one is f of x, g of x. So, we're like factoring out the f of x plus h. Okay? Factoring out f of f of x plus h doon sa ating first and second term. Okay? Plus, at this point, ano naman yung ating pwedeng i-manipulate? Okay? We are going to factor out, ang common sa kanila is g of x. So, we have g of x times the quantity f of x plus h minus f of x divided by h as h approaches 0. So, right now, meron kang dalawang expressions who are in factored form. And they're combined by addition. So, katulad ng ginawa natin doon sa rule number 4 para sa sum rule, let's break this into two limits. So, we'll have the limit of yung first natin, f of x plus h times g of x plus h minus g of x divided by h as h approaches 0 plus the limit of g of x times the quantity f of x plus h minus f of x divided by h as h approaches 0. So right now, since it is yung numerator natin is in factored form, so pwede siguro nating um kunin din yung product ng limits. That is the limit of f of x plus h, okay, as h approaches 0 times the limit of g of x plus h minus g of x divided by h as h approaches 0. This is the first term plus the limit of g of x divided by or as h approaches 0, okay, times the limit of our f of x plus h minus f of x divided by h as h approaches 0. So, right now, we have this product of expressions, two expressions, and all of these terms have limit expression. Okay? So, product ng dalawa, and then these two product din nila. And if you're going to analyze the situation for limit of f of x plus h as h approaches 0, still, this is equal to f of x. So, pwede siguro nating ilagay dito na lang f g prime is equal to our f of x, and then yung limit definition for the derivative of g. That is your g prime of x plus our limit of g of x as h approaches 0. So g of x still, and then f prime of x. So this is the proof for the derivative of the product of two functions. And then for number 7, we have the quotient rule. Hindi ko na ipapakita yung proof niyan. So I want you to discover the proof of the quotient rule. And aside from this first 7 rule, we also have the rule for the exponential and logarithmic functions. These are available on your reading material. So derivative of e raised to x is equal to e raised to x. Derivative of a raised to x is equal to a raised to x ln a. No, take note that yung e dito na base for a raised to x is the Euler's number. So, we have this natural e, whereas for a raised to x, yung a naman dito is a real number. So, a raised to x is equal to a raised to x, or the derivative of a raised to x is equal to a raised to x ln a. We also have derivative of ln x, and that is 1 over x. Derivative of the logarithm of x base a is 1 over x ln a. Next set of rules are for trigonometric function. We have for sine function, cosine, tangent, cosecant, secant, and cotangent x. And all of these are available also in your reading material. Um, take note na hindi ko na din ito papakita yung kanyang proof, but you can discover and use the limit definition of the derivative to derive the proof of this. Okay, last set of rules are for inverse trigonometric functions. We have inverse sine function, inverse cosine, inverse tangent, inverse cosecant, and inverse secant function, and lastly, inverse cotangent function. So, yung last part of this video will be about the examples applying the rules for the derivatives. Okay, so I'll be sharing some examples about this and how to apply or to apply these differentiation rules.